Good morning, everyone. I'm Carlos Recalde from Sheltered Harbor. I want to welcome you all to a Cloud Vaulting for Mainframe Data webinar that Sheltered Harbor is hosting with our alliance partners, 21CS, and Josh Stiles will be giving you some nice presentation. And with AWS, where Pradeep will also join and give us his side of the presentation. So a couple of quick things for the morning. First off, we encourage you to ask questions. Put them in a text and we will get to them. If we can get to it quickly, we will. I can assure you that every question asked will be answered, if not during this call, at least as a follow-up email. You will also get copies of the slides, and this is being recorded, so we will have a recording available for you to distribute to whomever you think this content is appropriate for. So let me kick off with a quick introduction to Sheltered Harbor. And Cassie, if you can move the slide over. Most of you, or many of you, are aware, Sheltered Harbor's mission is unique. We were created by the industry specifically with the intent of what do we do if an extreme outage occurs at a financial institution. And the biggest concern that we collectively had was since 2015, when this came together. At the time, the general market didn't have a whole lot of experience with institutions being dramatically knocked out by a cyber attack. We recognized that was a possibility and said we need to have a way of maintaining public confidence. And Sheltered Harbor was created with that mission in mind. We didn't know at the time what the answer was, but that's our mission. If I can go to the next slide, I want to get to specifically what our mission is and what we've done. And recognizing that the scenario we were talking about was really about resilience. At the time, we were created by 30 plus financial institutions and associations, and basically a strong representation of the industry. And the concern came about from a public-private exercise. We had everybody on the regulatory and law enforcement and DHS side on the public side of this exercise. And on the private side, we had a broad collection of 30 plus organizations. And as we postulated that scenario of what would happen, it became clear to everybody that we collectively didn't have a good answer. We didn't have an answer. And that by itself was a problem because not having an answer, not being able to back it up, was going to create a problem with public confidence. The real concern was runs on banks if this happens to the wrong organization. And so the after action from that, or an after action from that exercise, was that the industry got together and said, let's put together an initiative to solve this problem. Sheltered Harbor came about, and we recognized that although my board at the time was all CISOs, they were all focused on preventing the scenario we now were having to react to, realize that this is resilience and not security. And so we were the first, and at this point, probably the only industry organized and focused and dedicated specifically on resilience, and particularly in Sheltered Harbor's case for recovery from a significant event. Let's move on to the next slide. As you see the three pillars of Sheltered Harbor. We're going to spend time on that first one, the data vaulting. But let me paint the scenario first really quickly. Most of us recognize this. Bank is working just fine until at some point during the day, something goes wrong. And in this case, it's something really bad. All systems are affected, no access to data. And fundamentally, what's happened at this point is our customers are disconnected from their assets. As a financial institution, we are the connection point between the customers and their assets. And we are the record keeper of that. And without those records, nobody knows who owns what. So the concern was if we don't make that connection happen back very quickly, we're going to lose confidence from not only those customers, but everybody they interacted with or transacted with. And we have a serious problem. Now, if the institution can recover very quickly from that problem, then great. That's what we do very, very well. We have disaster recovery and business continuity plans, and we rely on that as an industry. However, the scenario that we were talking about here was a dedicated cyber attack, predominantly, but not exclusively, something that completely wipes out operations, and we realize it's going to take us many days or, heaven forbid, even weeks to recover. In that scenario, the customers are disconnected from their assets, and if that goes on too long, we're going to have panic. So, Sheltered Harbor recognized two critical things at that point. Number one, time is of the essence. Number two, we don't have to have everything in this bad scenario. We just need enough to keep customer confidence. In the case of banking, for example, collectively the industry at that time, over 300 subject matter experts, determined that if we can provide customers with some real confidence that we know what their balances were and that they can see their balances in all of their accounts, and we can fairly promptly thereafter give them access to funds from those balances, we're going to maintain their confidence. We haven't recovered the organization yet, but the business continuity plan will do that, but at least we're maintaining confidence. So that's what Sheltered Harbor came up with, a way to do that. If we can move on to the next slide. In order to do that, um, we said, okay, we have to be able to recover those critical business services. And what are they? I just told you in the case of banking, what the industry has agreed. Each institution has to figure out what are my critical services. And typically, nowadays, the concept of minimal viable operation is floating out there. The regulators in Europe have basically put this right into their DORA regulation. They want organizations to actually define and determine what that minimal viable operation is or operations are, and make sure that they have a mechanism to recover those and deliver these either continuously or very quickly after a significant disruption. So it's all about critical business services, and that's what Sheltered Harbor focused on. Initially, in the case of banking and brokerage, just those two services. Don't worry about everything else, not because we don't have to do it, but because it's not as critical as those two services. But in order to do that, we have to have the data. If we can go to the next slide, the first thing that Sheltered Harbor did was define a method by which we could be absolutely sure that even when all those systems are gone and all copies of data are lost from our backups and our secondary systems, we still have a copy of data in a vault that is isolated and completely clear of whatever may have affected our production and backup systems. And that we call the Sheltered Harbor data vaulting process. And the process has some critical characteristics. We're very specific about what data must be there. We're very specific about exactly how we protect it. How's that vault truly cyber resilient? And it comes down to the characteristics you see underneath there. It's got to be isolated. It's got to be mutable. We got to be able to get to it after everything else is gone. The process that puts the data is equally important to what the vault is. If what we put into that vault was garbage, we're in trouble on the worst of days when we're counting on having it. So we want a secure process. And lastly, we want to be able to recover that when everything else we have is lost or unreliable. So we want to recover it into a zero trust platform. That is Sheltered Harbor's model around data vaulting, and it's around not only the putting the data into the vault, but also pulling the data out of the vault into a recovery platform. If I can go to the next slide, because now I want to get to today, we're focused specifically on data in the mainframe. And the reason for that is, well, many of you, obviously, if you're on this call, this is relevant to you. The crown jewels, as most of us call it, is sitting in that mainframe. And, as I mentioned, we were started by a broad collection of the industry. Uh, our founding members include the largest financial institutions in the US. Not surprised they're sitting there with data in their mainframe. And we had a few of them said, hey, but it's in the mainframe. This is my most protected environment. You're asking me to move it away from there to keep it protected. It's kind of, doesn't make sense to me. And the concern was that the mainframe was the bastion that we keep most protected, and moving it out to something else exposes it to some new risks. Sheltered Harbor came up with a very clear process by which that happens. And on the left-hand side, we have our operating environment. And if you're in a mainframe, you need to move that. You need to select. You need to identify, and you need to collect that data. You need to move it into. If you want to move this into a cloud, which is what a lot of organizations are doing, Sheltered Harbor doesn't require that, but we see that largely out of practicality and cost is moving to the cloud. Our other partner, AWS, is on with us because we've worked closely with them on a cloud architecture that absolutely meets Sheltered Harbor's requirements for moving that data, isolating that data, retaining it in an absolutely secure vault, and inevitably also moving it out to whatever would be the recovery platform. So Sheltered Harbor defined the process, the controls, the security, and inevitably a certification that ensures this happens right. But when we're working out of a mainframe, if we want to go from a mainframe directly to the cloud, 21CS is your answer for that. And I'm going to hand this over to Josh, who's going to give you more specifics about how that happens.
Yeah, thank you, Carlos. Thank you for going over the Sheltered Harbor principles and requirements. And now I'm going to start talking about how you can leverage a 21CS solution with AWS to help with that Shelter Harbor compliance. So can we go to the next slide, please? So obviously, the mainframe itself is very resilient, but that doesn't mean you shouldn't have a resiliency plan in place. And many organizations do have good resiliency plans in place as it stands right now. But as we see in this day and age, cloud and cloud object storage has become a very hot topic. And there's a lot of benefits for having some type of third or fourth site with cloud and cloud object storage, being able to store it in a different region. But when we were coming up with this solution, we really started to talk with customers and try to understand how are they incorporating cloud and specifically cloud object storage into their mainframe resiliency plan? Have they started even talking about cloud object storage as just another storage tier to their mainframe or ZOS environment? Or are they not, at that level yet? But have they started to think about how they can incorporate cloud object storage into that plan and become even more resilient than they are now? And, those clients that have started that journey, how long has it been taking to get that data back to the platform if some event did occur, right? Carlos did mention that getting the data back to the platform in a speedy fashion and in the right amount of time is important to getting that application back up and running and disrupting the end users as less as possible. So, how do you get the data back to the platform? And when we start looking at the different tools that are out there right now to bring the data back to the mainframe environment, we see a couple of different legacy tools that are out there. Most clients and most environments are implementing some form of SFTP or FTP for moving data out to any target, right? It could be cloud object storage, it could be some type of distributed system, some other storage provider, something like that, right? But FTP requires additional servers, extensive setup to operate. You can't really pull that data back to your target or where you sent it from very easily. And that just means you don't have control of the data, right? The most important part of your resiliency plan is keeping control of the data and making sure that you can bring it back to your platform at any given moment. And then there's obviously network attached storage, right? Decent to start sharing some type of data, but when it comes to your resiliency plan and storing backups and making sure that those backups stay protected, that can introduce a single point of failure. It could also expose different threat actors or expose the data to ransomware, and it really lacks that immutability that Carlos and Shelter Harbor is looking to do with your backup data, so you stay resilient and able to make sure that the data that you are recovering back to the mainframe platform has been untouched, and can come back quickly. So this is where the 21CS offering, Stratus, comes into play. It's a native ZOS software that is designed to efficiently and safely transfer data to and from S3 Cloud Object Storage at scale. And let's break that down for a second. We're saying to and from, so it's bi-directional. It's no longer just sending the data from the mainframe to Cloud Object Storage and having no control. With Stratus, you keep control of the data. If you wanted to send the data or your mainframe data out to Cloud Object Storage for 2 or 3 hours and pull that back, you have that ability to do that. there's no additional server setup as well, right? It's using industry standard APIs. We don't need an intermediate server in between to communicate from the mainframe to cloud object storage. We're leveraging those APIs to connect directly to cloud object storage. And when it comes to security and credential management, obviously you need some type of access key or some type of access to cloud object storage. And with Stratus, that is built into the product from the ground up. As an admin with Stratus, you have the ability to control who can send data to your cloud object storage environment and what container they are able to access. So you're able to really put a lot of controls in from the ZOS side. And why we're here, right? You're able to create those protected copies of your backup data, right? Be able to put them into an object lock or a mutable type environment and make sure that that data doesn't get overwritten or that data doesn't get corrupted in any way. So you're able to put that write once, read many type of object lock on it. So end users could use the data, but at the same time, it's not getting corrupted or overwritten. And then the ability for us to bring that data back to your ZOS environment really comes from being able, we send metadata out with every data set that we move to cloud object storage. So when you do have that recovery event that you need to bring your backup data to your ZOS environment again, it can allocate that data set very easily because we have the data set allocation stored with each object out in cloud object storage. Now that's just kind of the basis of the product, but there's a lot of there's some other benefits with Stratus that you can take advantage of outside of just, protecting your copies of data and having it stored in a cloud object storage environment that's secure. Next slide, please. With Stratus, you're able to convert any of your ZOS data from EBCDIC to any code page. And obviously the most common code page for distributed in cloud environments is UTF-8 or ASCII. And that allows you to start sharing that data with the rest of the enterprise. Now, you're probably not going to do that conversion with your backup data because you want to keep it in the same format or you want to keep it in EBCDIC so that if it was sent out to cloud object storage, you can bring it back very easily. But other static data that you have, you can send it out to cloud object storage and now really take advantage of cloud object storage, and maybe some hybrid cloud applications can take advantage of that data. With Stratus, we help reduce your tape footprint as well by migrating cold tape data or data that's on ML2 to cloud object storage. And we can really show what the cost savings would be by moving that data out to MLC or cloud object storage. And the best thing about Stratus is you can set this up to be automated, right? We have batch commands that you can put at the end of existing batch jobs or new batch jobs that allow you to really have kind of a hands-off approach when you want to move your ZOS data or ZOS backups out to cloud object storage. And really saying all this, it helps amplify your hybrid cloud strategy by incorporating a very easy to use tool that's native to ZOS and the mainframe to send just, maybe it's you just start with your backups, but it opens the door to different possibilities to really leverage cloud object storage as another storage tier for the mainframe. Next slide, please. So how does this all come and play with AWS? And Pradeep in a second here is going to talk about the AWS Cyber Vault or Cloud Vaulting offering. But really with Stratus and AWS, we've become a powerful duo for resiliency. As I mentioned before, we have native software with Stratus that works on ZOS and uses the industry standard APIs that AWS offers to make that transfer of your backup data as seamless as possible. There's no additional servers required to help with that transfer of data. And we have the metadata stored for an easy recovery back on ZOS if you had some type of event. And Pradeep is going to go into this a little bit more in a second, but with the cloud and any cloud object storage, you have a lot of different controls that allow you to keep that data safe and keep others from accessing that data and really have a immutable type of environment that you know your backups from the mainframe will remain safe. So Pradeep, I'll hand this over to you.
Cool. Thanks, Josh. Hey, everyone. So now that you've heard from Josh on how you get your data from mainframes onto the AWS cloud, I want to take the next few minutes to talk about uh, why and how are our customers using AWS to protect their data. Next slide, Cassie. So the first thing I'd like to spend a couple of minutes on is why are some of the largest financial services customers using AWS to build their cyber data vault and protect from ransomware. So one of the first reasons that we have seen is customers are looking for an easy to get started solution. They want to start small. And then, as and when they add data, they want to be able to scale the platform. So that's something that you get to do really easily with the cloud, especially with our services such as Amazon S3 and AWS Backup. You don't have to assign large amounts of storage. You can start really small and then you can just keep on adding to that. So that also gives you the agility to change the architecture how you see fit. So it gives you both of those advantages, and it's also very cost effective. So you don't have to like pay for large amounts of infrastructure beforehand as you have to do with your on-premises environment. And the other main reason that we see is because customers want infrastructure that's already been attested by other organizations. So, for example, our Amazon S3 and AWS backup services are already like we have already gone through the requirements for data immutability, and they've been approved for use by various different financial services institutions. And as Carlos alluded to some time back, we've been working with Shelter Harbor over the past 1.5, 2 years to come up with an architecture that solves for Shelter Harbor specifications, but also meets some of the basic cyber event recovery platform requirements. Next slide, Cassie. So now that I spoke about why some of our customers are using AWS, I wanted to spend the next 2 minutes on how are they doing it on AWS. So the first thing that I wanted to mention here, this is a very high-level functional architecture diagram. We have implemented this in detail for a lot of our customers, but if you look at it, there are three main requirements that we are trying to solve. The first thing is digital air gap. So we want to ensure that no one who has access to your production environment or unauthorized access to your production environment has access to your data vault as well. So what we have done here in this diagram have introduced something called the ingress zone and the egress zone. So data that's coming in from any of your environments, any of your mainframe environment can land at this ingress zone, and then the data is pulled from this ingress zone into the vault zone. So we are introducing a buffer here, like an S3 bucket or even AWS backup that gets the data from one S3 bucket and then pulls it into the vault zone. So that's how we introduce digital air gap here. And the second requirement is data immutability. So we have services such as AWS Backup and Amazon S3, which has data immutability features. So you can implement data lock features, which ensures that once the data is written into the vault, cannot be modified or updated or deleted for how many ever days you configure it to. So for example, if you set it to store the data for 35 days and no one should be able to modify or delete it, then that's what it'll do. No one, even from AWS, can touch or do anything with the data. So that's what is being implemented at the vault zone. And the last one is the analytics. So you want to ensure that the data that's being written into this vault is not compromised in any fashion. So what we have introduced here between the ingress zone and the vault zone is the analytics zone, which is where the data is scanned for ransomware or malware before it's written into the vault. So you could write your own custom scripts here to check for data. You could use partner solutions. We have used partner solutions such as Elastio that goes through the data and then be able to write data to the vault. We also have AWS services such as Guard Duty that you can use to scan data on Amazon S3 before it's written. And the other two zones that you're seeing, the egress zone and the forensic zone. It's only you use that only when you want to recover the data. So once you have written the data into the vault, you also want to ensure that the data is clean while you're recovering, in case you missed something in your analytic zone. So that's why you have your forensic zone to check for the data before you recover. And the egress zone acts very similar to the ingress zone. So you want to ensure that no one has direct access to read from the vault as well as to write to the vault. So we implement two different zones, the ingress zone and the egress zone here. So those are the main functionalities. Again, as I said, we have detailed implementation guidelines that we can provide as long as you can reach out to us. Now I'll hand it over to Josh, who's going to show you a demo of how this looks like from an end-to-end perspective. Josh.
Thanks, Pradeep. Thank you for going into some details around the vaulting offering. So this is a recorded demo, and it's just basically to show how you can use Stratus to send data out to AWS and get it into a vaulting offering. So with this, we have Stratus and we have what we call a hybrid cloud data management section of the product. And you have different options to send, retrieve, or delete objects to and from your cloud object storage environment. So we're simply going to start with a send. We're going to start with a data set, and you can do multiple data sets by applying a mask to it. You can also, when you create the object out in cloud object storage, you can name it anything you want to a naming convention that's standard to you guys. And then converting it from EVCIDIC to UTF-8, we're going to select no. Now it routes the command to our started task, which handles the communication to cloud object storage. And before we go to AWS to show the objects out there, I just wanted to quickly show in this demo that you have the ability to set up Stratus commands through batch jobs and be able to put this at the end of an existing batch job or set up a new batch job to help with that automated transfer of data out to cloud object storage. So here I just have a simple function that is taking data that I sent out from the ZOS to a single bucket, and that function is now transferring that object to my vaulting or my vault that I have set up out in AWS. And this is just to show that it went through. It's giving me different statistics of how many counts and duration that happened. And now if I go back to my buckets that I have configured, this is the original bucket that I sent my backup data to. It doesn't have that immutability, the object lock, but if I go to my vault, I can see that that same data set is now out in this vault bucket. And if I look at the properties, we have object lock enabled. We also have compliance mode enabled. That means the data has to reside for X amount of days. I have 1 day for now, but I just want to go back to something happened with the recorded demo. But basically the rest of the demo was going back to ZOS and being able to show that with Stratus, you could also check on those objects from just from ZOS and be able to list the objects that you have out in cloud object storage without having to go to the AWS console. So here I'm just selecting a container to list the objects from, and I can see all of my different objects here that I have out in a specific bucket. So I never have to actually leave ZOS once I have the AWS side set up. So that wraps up our webinar. If you want to start utilizing your cloud without compromising your security, feel free to reach out to any of the different organizations here, from Sheltered Harbor to AWS, and having a potential of a workshop. And then if you want to learn about Stratus and how we can help with transferring that data from ZOS to cloud object storage, please feel free to reach out to the 21CS team as well.